Okay, so yesterday we finished on about dynamic partition. Okay, so we saw that there are four ways in which processes can be allocated. One is the first fit, best fit, next fit, and worst fit. Okay, and then we look into that. Okay, so this is the explanation, and this is how it's being done. Okay, so now today we will continue with this. So we have a problem where we say if there is not enough space inside the memory. Okay, so memory, which I mean is the physical memory. Yeah. So as you go along this chapter, they will use two concepts: physical memory and main memory, and secondary memory. Okay, so physical memory is your RAM, but sometimes in this particular book, they also say main memory is also physical memory, which is equivalent to your RAM. Okay, but secondary memory in this book means that it's your hard disk. Okay, so bear in mind, if you come across the notes in these slides or in this chapter, when you see the word main memory, physical memory, it both means your RAM. Okay, physical memory and main memory equals to your RAM. When the slide or the book says secondary memory, so that means your hard disk. Okay, all right. So we have a problem here called external fragmentation, whereby there is empty spaces like this here. There are empty space here. This diagram is what we say as the your physical memory. Okay, physical memory. All right, which is your RAM. So like I mentioned yesterday, the top part normally is usually given to the operating system, and in each location here, the processes come in. All right, and as the processes leave, there are empty spaces in between here. So this empty space is about 100K, 300K, and 260K. So if the process is coming here, let's say there is a new process which has the size of 600, it cannot go here, it cannot go here, and it cannot go here because it's not enough. However, if you accumulate this empty space, this empty space, and this empty space, then you have enough space to reach 600. Okay, so the process by which the operating system shuffles these empty spaces is called compaction. Compaction means shuffle memory content to place all free memory together in one large block. So this is how it's being done. 100, 300, and 260. When you shuffle together and you put it all at an empty spot here, so you get 660K here. So now if there is a new process coming in with a size of 600, it can be gone inside this. It can be put inside this location here. If you did not do compaction, then it's difficult to put the process inside here. Okay, so this is the solution for external fragmentation. What is external fragmentation? Empty spaces which is outside the process. This empty space here, this empty space here, this empty space here. Okay, all right. There is also another method in order for you to solve external fragmentation, which is called the paging. Okay, paging. Paging means to allocate the process non-contiguously. Always remember, when we say non-contiguously, contiguous means the process is not broken down. Non-contiguous means the process is now distributed. That means it's not in a particular order. It is now broken down into several sub-processes. So non-contiguous means it is not side by side. It is broken down into several locations. Okay, so this is how paging looks like. Okay, this is a bit tricky here. Paging is a memory management technique in which the memory is divided into fixed size. Okay, memory mana? Memory this one. Physical memory. What is physical memory? Physical memory is your RAM. Paging is used for faster access to data. It is a logic concept. Okay, so in compaction, we reshuffle the location. It's pretty much simple. But in paging, we break down because the memory here has not enough space, so we break down the process into several sub-processes. Okay, several sub-processes. So each process is broken down into several sub-processes. Unlike compaction, the process is not broken down. But in paging, the process is broken down into several sub-processes. Each sub-process is called a page. Okay, a page. So dia satu proses is broken down into several pages. Okay, then you have the virtual memory. What is virtual memory? So virtual memory is part of the secondary memory. In this diagram here, okay, let me just show you what is virtual memory. So virtual memory is part of this memory, where is part of the hard disk. Okay, so virtual memory is part of the hard disk. So what the operating system will do is, because there is not enough space inside your RAM, so they will take this, create a virtual memory, and put it down inside here. So now, this I write it as VDM. So now your RAM is way much bigger than the original RAM size. Okay, that is one. Number two is, each process is now divided into pages. What is pages? Sub-process lah. Sub-process. P. Okay. Meaning, one process is now divided into several pages. Okay, so this one is actually referring to this one. All right. Okay, so since the process is now divided into several different pages, so some of the pages will be kept inside the physical memory, some of the pages will be kept inside your secondary memory or your hard disk, and some of the pages will be kept inside the virtual memory. Virtual memory ini sebahagian daripada physical memory lah. Okay. Alright. So next, let's from this diagram. So this is a CPU. Alright. So this, kalau file tu nak refer to something, let's say it wants to refer to a specific sub-process. So there will be something here, map, memory map. Memory map is to map this page here dengan physical memory. So dia nak cari location file tu kat mana. Okay, we'll come to that shortly. Okay, so but what I need you to understand is, paging is whereby a process is divided into sub-processes, or what we say as pages. Page. Okay, page. All right. So this is how your virtual memory looks like. So cache memory is always just before your CPU, and memory is here, and virtual memory is part of your hard disk. Okay, so when the RAM size is full, operating system will now create a new RAM, which is called the virtual memory, and the location is part of the hard disk. How big can the virtual memory be? You can set the size. Yeah, the percentage lah. That means you only take 5% of your hard disk ke apa ke, you can set. You can just go into your Windows setting and you can find this virtual memory setting. It's already there by default. Okay. All right. Next, we have another problem: internal fragmentation. So internal fragmentation is allocated memory that is large than a process. That means the size given inside the memory is big, but the process tu kecil pula. So ruangan kosong yang berada kat dalam. Okay, ruangan kosong yang berada kat dalam. So the size given is big, but the process is small. It's like, for example, you pakai seluar besar lah. Okay, you are given that big, but you are very small. Okay, let's say you are given a big t-shirt XL, tapi badannya S. So yang what do you say, the balance of the size tu is what we say as internal fragmentation. Why is it called internal fragmentation? Because it cannot be shared with another process. It's internal only to you. Yalah, awak pakai t-shirt XL, badan S. You cannot share the remaining balance tu dengan dalam t-shirt tu dengan another S. Tak boleh lah dua orang dalam satu t-shirt. It doesn't work that way lah. Okay, so it's only internal to you. Cannot share that size, that what do you say, that empty slot to someone, and you cannot use that slot. Okay, so that is what we say as internal fragmentation. So internal fragmentation pun akan ada dia punya cara-cara untuk solve dia. Okay, so now we go back to non-contiguous, main paging tadi. So non-contiguous is whereby satu proses be divided into sub-processes. Why do we do so? Because your memory inside the physical memory or inside the main memory size dia tak cukup. So we break down the process. Operating system akan break down the process. Okay, which process is most important? Masuk dulu dalam your RAM. And if there is a need to call another process, another sub-process, then the operating system will work. There is a calculation or there is a method to remove the process from the RAM, physical memory, and to re-include a new file. Okay, so paging is non-contiguous. Okay, so this is how paging is done. This is the formula. All right, let's show you this diagram. Okay, so this is how it looks like. Okay, so this is the CPU. And this is a page table. Page table ini ialah sebahagian daripada your RAM. And this is the physical memory. Physical memory itu di mana? Physical memory is your RAM size. Okay. Since now we have broken down each process into sub-process, or what we say as pages. So now the process or the files are kept here and there. Some files are kept in the physical memory. Kalau tak cukup, dia akan simpan dalam secondary memory, which is inside the hard disk. Okay, so let's say CPU now is running and it needs a specific file. So once it needs a specific file, CPU akan keluarkan, okay, now I want to get this particular file. This is the address. It will tell the operating system. Tapi address yang dia bagi dalam bentuk logical address. Okay, this is the address. So what is it? Operating system will take this logical address, compare dengan table ini to find the physical address. Kat mana located this particular file? Once it has located the physical address of the particular file, it will transfer back the file to the CPU. Okay, itu sahaja, very simple. So it's as if like this. Let's say we are now all in a classroom, and each of you is a particular process. Okay, and I am the CPU, and I tell you that I want a book on something, and the book is kat luar. So I only tell you the book, but I don't tell you the page number. So you have to go and find out what is the page number of that particular book. So when you bring the book, so you have a page number on that particular book. But I might just say, okay, I want chapter 5. But the exact page number only you would know. Because I do not know chapter 5 tu page mana. Tapi saya tahu dia punya heading tu chapter 5. So you will go refer balik kepada buku tu and you find, okay, chapter 5 rupanya in page 70. So you give me that particular file. Okay, so let's go into let's go into the calculation mode. Okay, right. So sebelum tu, remember this formula. Physical address bersamaan dengan frame number multiply by frame size plus offset. Number of pages bersamaan dengan program size divided by page size, and number of frames sama dengan memory size divided by frame size. Okay, this is the formula you need to remember. Okay, saya bagi you 1 minit untuk salin formula ni, because we want to calculate, we are going to use this formula in the next few slides. So I give you 1 minute or 30 seconds just to copy down this formula so that we can go to the next slide. In the next slide, once we start the calculation, I need you to refer to this formula. Okay, so saya bagi awak 30 saat. We'll start back in 10:32. Okay, all right, let's go on. Okay, so in this scenario, how do you read this? Is whereby it's like this. Page 0, you refer to the page table and to find the location inside the physical memory. So the frame number is this one: 0, 1, 2, 3, 4, 5, 6, 7. These are called the frame number. Always remember, the frame number starts with the number 0. 0, 1, 2, 3, 4, 5, 6, 7. Okay. The size of this frame number and this page number is the same. Okay. The size of the page number equals to the size of the frame number. Always remember that. Okay. All right. So let's say we have, kat sini ada berapa frame? 1, 2, 3, 4, 5, 6, 7, 8. Walaupun ada 8 frames, but frame number starts with 0. So your calculation will start, your numbering will start from 0 to 7. Let's say we have a program size of 60, total program size of 64 megabyte. Okay, and we have 8 frames. Okay, so soalan kata we have total program ialah 64 and we have a frame bersamaan dengan 8. Okay, soalan dia ialah what is the size of the frame? Apakah size frame ini? So 64 divided by 8 equals to 8. So 8 ialah size of each particular frame. Size dia, this one here. Size dia. Kenapa saya bagi 8? Sebab soalan kata ada 8 frame. Bukan 7, it's 8. But the numbering is done by 0 to 7. Tetapi kiraannya ialah 8. Alright. So total program kadang-kadang dia beri 64 and dia kata frame sama dengan 8, so 8 lah. Okay. Okay. So again, Frame number, size of the frame number equals to the size of the page number. Okay. Cara you baca diagram ni ialah page 0, which is this one, is inside frame number 1, which is this one. Page 2, which is this one, is inside page 3, which is this one. And page 3 is inside frame 7. Here, this one. Cara baca dia. Page 1 is inside frame number 4. This one. Okay? Alright. So in this case pula, we have how many frames? 1, 2, 3, 4, 5, 6, 7, 8 frames. Tetapi kiraan dia bermula dari 0 sampai 7. Okay, we have 8 frames. How many pages do you have? We have 4 pages, which is page 0, 1, 2, 3. So all of this, page 0, refers to this, which is inside frame number 5. Okay, where is frame number 5? 0, 1, 2, 3, 4, 5. So this refers to this one here. Page 3, bukannya page 4, because this box is page 0, page 1, 2, 3. So page 3 is inside frame number 2. Where is frame number 2? 0, 1, 2. So it's this one. Nampak ni? MNOP. Okay. Let's say page 1. Page 1 is inside frame 6. So page 1, frame 6. This one. 0, 1, 2, 3, 4, 5, 6. This one here. And last but not least, page 2 is inside frame number 1. 0, 1. Okay, this one. Okay, that's one. All right, are you with me? Faham tak?
Faham, sir.
Okay.
Faham, sir.
Cuba buat soalan ni. Given a physical memory of size 64 bytes, the page size is 8 byte and the page table is as below. Okay? So what are you given? You are given the physical memory of 64. Physical memory 64 tu di mana? Physical memory 64 tu ialah this one here. This one here. So they're saying physical memory secara keseluruhan is 64. Okay. And page size ialah 8. Page size, this one here, ialah 8. But we mentioned just now, page size sama dengan frame size. Page size sama dengan frame size. Okay. And page table. Page table di mana? Page table di tengah-tengah. Okay. Alright. So you have the page number, you have the frame number here, you have the total total size of the physical memory, and you have the page size. Okay. So semua dah ada. Next, the question is, calculate the physical address for logical address 2310. Okay, 2310. Okay, let's do this. Okay, let's do this. Macam mana saya buat? Okay, tak apa. Saya buat je lah. Okay, so physical address for each logical address. So soalan kata, find the physical address. Physical address di mana? Physical address is your RAM. Logical address di mana? Logical address comes from your CPU. So inside paging, when the logical address comes out, dia akan datang dalam bentuk ini. 2,3 atau 1,0. Dia ada 2 numbers kat situ. So the first number, this one, is referred to as page number. Salin, eh? Number 2 here is what we say as the page number. And number 3 here is what we say as the offset. Okay. So yang ni, satu ni ialah page number, yang keduanya ialah offset value. So daripada logical address 2,3 and 1,2, we are supposed to find out what is the physical address. Kita kena cari what is the physical address. So biasanya short form untuk physical address ialah PA lah. PA. Okay. So kita ada formula dia. So now let's go and look back at the formula. Ni formula. So physical address bersamaan dengan frame number darab dengan frame size campur offset. Okay. Kalau kita masih ingat soalan tu ada offset. So shouldn't be an issue. Okay. Shouldn't be an issue. Okay, let me just let me just copy this for you, it'll be easier. Alright, so nampak better this way. Okay, so you are given, you are supposed to find the physical, you are supposed to find the physical address given the logical address of 2, 3 and 1, 0. Okay, so let's do the first one. 2, 3. Okay, 2. Logical address 2, 3. Okay, saya tulis short form dia LA. Okay, so logical address 2, 3 kita nak cari dia punya physical address. So look back at the formula kata physical address sama dengan frame number multiply by frame size. Okay, what is the frame number? Frame number telah diberi di sini. What? Okay, what is this? Kalau you masih ingat tadi, this nombor 2 ini ialah page number and nombor 3 ini ialah offset value. So page number bersamaan dengan 2 is 3. So frame number is 3. 3 multiply by frame size. So kita tak tahu lagi. Frame size, saya tulis FS. Campur dengan offset. What is the offset? 3. Okay, so 3 multiplied by frame size plus what is this? 3. Okay, so now if we remember, nak tahu frame size, number of frame size equals to so kat sinilah jawapan dia. The number of pages bersamaan dengan program size divided by program size divided by page size. Page size telah diberi, pages telah diberi, number of pages, number of frames. Okay, number of frames kita tak tahu lagi. Okay, so we have memory size 64 divide by, sebab kita kata frame size bersamaan dengan page size. So we divide 64 divided by 8, we get 8. So 8 is what we say as the page size. Okay, page size. So page size we say it's the same as, okay, we say as it's the same as frame size. So gantikan 8 ini dalam ni, so 3 multiply by 8 plus 3 have as apa jawapan dia? 27. 27. Okay. All right. Now, let's try to do the second one. The second one is 10. 10. Okay. So what is the physical address of 1, 0? Cepat. I give you 2 minutes to answer this question. Siapa boleh jawab? Just on your mic and answer. Okay, what's the answer?
12.
12. How about others? What do you get? Yang lain dapat apa? Page.
Tak tahu silap kot. Saya dapat 32.
32. Okay, next answer. Siapa yang dapat 32? Siapa yang dapat apa tadi? 8 apa? 12. Okay. So the logical address, sorry, the logical address is.
Sorry, saya silap.
Okay,
Okay, betul 32 sir.
Betul ya 32 ya. Betul
32.
lah. Betul 32 lah. Hai. Yes, correct. The answer is 32. Ada yang tak faham tak? Okay, it's quite simple je. Okay, you have to remember the formula and you just masukkan formula je. But always remember, bila logical address, bila dia keluar tu, dia keluar dalam bentuk dua number, which is the page size, comma, offset. So dia keluar macam tu je. Okay, it comes out in that particular form. Okay, let's look at the next one. Okay, now yang B ni, maybe our B ni is a bit tricky sikit. Saya biarkan untuk awak berfikir nanti. Let's do the third one. Page number and offset for logical address. Page number and offset for each. Okay. Okay, tak payah. Yang tiga itu nanti. You do the second one. Logical address for each physical address 15 dan 37. In this question, you are now given the physical address, tetapi disuruh kira balik logical address. Okay, so 15 and 37. Okay, so now you are given physical address. Apa namanya tadi? 15 and 37. Yeah, 15 and 37. Okay, so count the logical address. So again, saya kata tadi logical address hendaklah dalam bentuk dua number lah. Page size, comma, offset. Okay, so now let's try to do this one. And what is the answer for this? What is the answer for logical address for physical address 15 dan 37? Saya bagi 2 minit untuk kira ni.
Sir, logical address ni macam mana tadi? Saya lupa.
Logical address tu dia dalam bentuk dua form lah. Macam ni. So jawapan awak nanti hendaklah dalam bentuk macam ni. So cara you baca logical address ni, yang pertama dia ialah page number and yang kedua ni ialah offset value. Sama dengan physical address lah. So you pakai formula nombor 1 ni. Sekarang ni soalan kata dia dah beri dah 15. So physical address telah diberi. So awak kena cari dia punya logical address dulu. Terbalikkan saja. Kalau soalan pertama tadi dia beri logical, awak cari physical. Sekarang ni you terbalikkan benda tu. You kena cari logical address untuk physical address yang telah diberi. Dapat tak? You get it? Siapa tak dapat? Siapa dapat? Sekejap let me show you. Let me stop this first. Senyap Come on.
Sir, yang 37 tu
37 mana?
dapat.
Soalan tadi kah?
Kan 15 dengan 37 kan?
Correct.
Yang 37 tu soalannya macam kita kena rujuk yang table tadi tu lah kan?
Correct.
Lepas tu
Okay,
macam
wait. Never mind. I know saya merasakan awak semua tengah pening. Betul tak? Tak apa. Jangan risau. I will give you the answer. Let me explain to you the first one dulu. Mungkin daripada itu you boleh dapat jawapan untuk the second one. Sekejap. Okay. Okay, can you see this? Nampak tak diagram ni? Nampak tak diagram ni?
Nampak, sir.
Okay, right. So this is the answer, the method of how you calculate for the logical address of physical address 15. Okay, so the question says dia dah diberi physical address 15, so which is this one lah, atas ni. So kalau you got formula, physical address bersamaan dengan frame number kali frame size atau page size campur dengan offset. Okay, so inilah formula di bahagian tengah ni. Okay, so this is the formula. 15 equals to frame number multiplied by page size or page size or frame size plus with your offset. So memang tak tahulah offset tu berapa. Okay, so in this question you have to start drawing balik. Okay, so kita lukis, saya lukis di sini, this one diagram kat sini. Okay, this particular diagram is your physical memory. Okay, kenapa saya buatlah 7, this is your physical memory. Okay, alright. So kenapa saya buat 8 frame size? Sebabnya kalau you tengok balik soalan tu, soalan kata 64, right? Total dia 64 and each page size atau frame size ialah 8. So bila kita bahagi, kita dapat 7. So saya lukislah 8 boxes here. Bahagi ni dapat 8 lah kan. So saya lukis dah 8 bahagian kat sini and saya numberkan melalui 0, 1, 2, 3 sampai 7. Okay. Kenapa 7? Sebab saya bermula dengan kosong. Alright. And then kalau you masih tengok soalan number 1, physical address ialah location dalam satu frame number. Okay. So saya carilah secara manual kat mana nombor 15 ni. So nombor 15 berada dalam frame number 1. So why do I say is number inside the frame number 1? Sebab kalau you masih ingat, formula kata frame size ialah 8. Kan dalam ni 8. So dalam ni 8 maksud dia 8, ini 8 yang kedua, ini 8 berikutnya, ini 8 berikutnya, ini 8 berikutnya. So address 15 ini berada dalam ruangan ini. So ini 8. So 9, 10, 11, 12, 13, 14, 15, it's inside this location. So this location is inside frame number 1. So that is why I replace frame number with number 1. Okay. Multiply by 8. 8 tu frame size lah. Okay, itu memang dah tahu dah. Okay, plus offset. Selepas itu saya buat calculation dia, saya dapatkan jawapan untuk offset ialah 7. Now, the answer for logical address ialah dalam bentuk 2 numbers, right? Dia kena ada bentuk page number or page number and comma offset. Offset sudah diberi. Now, page number tak tahu. So you refer balik pada table and then you find out that frame number 1 is inside page number apa. So bila you refer pada table tadi, you will find out that frame 1 is inside page 0. So inilah jawapan dia. Inilah jawapan dia. Okay. So frame 1 is inside page 0. Okay. Alright. Now, let's try to do, okay, remember this. Yo.
Kenapa physical address tadi kat nombor 1 tu, frame number 1?
Kenapa dia dekat sana? Good question. Kenapa dia dekat sini? Kenapa 15 ini berada kat sini? Sebab, saya besarkan balik. Okay. Sebab setiap satu frame ini size dia 8, betul tak?
Okay.
Betul.
8. So, kotak yang pertama, frame yang kosong ni 8. Yang kedua 9, 10, 11, address ni tau. Dia dalam ni address. So 15 ni dekat dalam inilah. 15 ni tidak boleh berada dalam kotak yang seterusnya. Sebab ini 8, kotak kedua 9, 10, 11, 12, 13 sampai 15. And then kotak ketiga 16, 17, 18, 19, 20. Dia continuous lah. Sebab kalau you masih ingat tengok balik soalan tu kata size dia 64 ni. So besar-besar alam ni daripada atas sampai bawah 64. So that's why 15 is inside here. Kalau you tengok soalan berikutnya cakap apa? Frame physical address berapa size dia? 30? Berapa? Ada tak? 30? Tak dengar.
Macam mana?
The next question, what was the frame size, the page physical address?
37.
37. Okay, saya tanya awak sekarang semua. 37 berada inside frame number apa? Siapa boleh jawab?
Frame number 4.
Frame number 4. Let's find out betul tak? 37. Yes, correct. Yes, 37 berada dalam page number 4. Frame number 4, which is this one here. Dalam ni ada 37. So bila you dah tahu frame number, you terbalik-balikkan je lah. You tengok page table, you terbalik-balikkan.
So yang tu patutnya 15 tolak 9 kan yang soalan tadi. Sebab frame number tambah 8 bukannya darab.
Oh, dia tambah? Saya tak... Dia bukan darab eh?
Saya tertulis darab kot.
Darab lah.
Darab ke tambah?
Dia darab ni.
Oh darab.
Ya.
Okay.
Kalau tambah maksud dia dah 5 semester saya mengajar ajaran sesat. Okay, tak apa. It's okay. Alright. Okay. Apa? Nampaknya awak semua berpeluh-peluh. So kita berhenti untuk hari ini. Okay. And saya tinggalkan awak dengan soalan nombor 3 ni. Soalan nombor 3 ni memang mencabar. Okay, memang mencabar. But if you can do it, it's good. Untuk saya sendiri buat pun kadang-kadang dia mencabar jugalah. Okay, I leave you with question number 3. You try and do it, and in the next class, we will start from this slide. Okay? Alright, thank you so much. And if you have any questions, please message me ke WhatsApp me ke apa. Okay? Alright. So thank you so much, and I'll leave you with question number 3. This question here, saya akan highlight siap. Okay? And we will start on the next class with this question. Okay? Alright, thank you so much. And insyaAllah, you have any questions, you boleh tanya sekarang. Kalau tak ada, nanti kalau you can just message me ke WhatsApp ke apalah. Okay? Alright, thank you so much. Assalamualaikum warahmatullahi ta'ala wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Salam sir. Thank you sir.
Waalaikumsalam, sir.